Welcome back to another tutorial in monitoring of forest resources. My name is Lutz. Today I'm not alone because I'm here together with a student from Italy. Her name is Alessandra and she is from the University of Tuscia.
Ciao.
And today we are going to explain something about the assessment of regeneration. If you look in the background here, we find a spot with a very high density of regeneration trees, so very small trees, in this case beech trees. But the occurrence of this regeneration shows a very high spatial variability. If you only look 5 meters to the left, you will not find any regeneration tree in this area. So the problem with the regeneration is that it shows a very high spatial variability, and we have many spots, many areas where we find no regeneration at all. And in other spots we have a very massive density like here or even much more. The point is that usually our regeneration plots are very tiny. These are very, very small plots because we have sometimes a massive amount of small trees and we cannot count or assess them on larger areas. Together with the spatial variability, we have the problem that we have very extreme observations. Many zero observations in our inventory where we find nothing, and a few observations with very extremely high values. The technique that we can apply in this case, if we have a lot of spatial variability, is a cluster plot. And you have learned this in the lecture already. A cluster plot is composed of several subplots that are selected jointly by only one sampling element. If you look on the board here, I have drawn a typical nested sample plot here that we would use to assess the standing trees. If we assess the forest regeneration in tiny plots, we usually combine this plot design with a cluster plot design where we have multiple small regeneration plots where we make our assessments. Such a cluster plot enables us to capture more of the spatial variability inside each single observation. And this will likely make our observations from different plots more similar to each other, and it will likely increase the precision. If you look on this picture here, you can imagine that there might be a very high density of regeneration here and a very low density here. If we split this plot into several subplots like we did it here, we are in fact calculating a mean, and this will make our observations more similar to each other. Very important in context of cluster sampling, these subplots are selected jointly, so they are not independently selected and will only deliver one observation from both subplots together. Okay, Alessandra and me, we have marked a regeneration plot with this temporary stick here, and it is exactly 5 meters north of a sampling location where we also install a nested plot. So at this position we will now install a regeneration plot, and these plots are usually quite small. We are using a radius of only 1 meter here, which means the area of this regeneration plot is only 3.14 square meters. A very tiny area, and you can imagine it will result in a very extreme expansion factor. I'm just using a folding ruler here for the 1 meter around this position, and I would now go around and I would count the regeneration trees separated for tree species and for height classes. So we are distinguishing in this case 3 different height classes and the different species. Alessandra has a tablet computer here with the Open Forest Collect mobile app, and she can directly enter the observations into the tablet. You have learned how this works before in another video. Okay, in addition to the number of individuals in the different classes, we are here also interested in browsing damage. So damage by wild animals who are eating these regeneration plants during the winter. The German winter can be very long. The raw deer is very hungry, and there's practically nothing to eat except the buds of the trees, and this is what they are doing the whole day. And we are very much interested in how much damage they are causing to regulate the hunting issue. Okay, let's start with our assessment. So I have my 1 meter radius exactly here. You can also use a tape. I'm using this ruler here. And now I start counting, and I already find a small beech tree here, very much damaged by browsing. So the species here would be Fagus sylvatica. This is for Alessandra now. And the height class is the smallest class that we distinguish, which is smaller than 25 centimeters. And in this class I find this number 1. So I would now look for other beech trees in the same height class. Since this plot is very empty, I can already see there are no other beech trees in this area. And this is probably why the roe deer damaged this one so heavily. But what we find is another tree species here, which is also damaged. And this is Sorbus aucuparia. So the species is Sorbus aucuparia. And it's not in the smallest height class because it is more than 25 centimeters. So it's in the medium height class, 25 to 50 centimeters. There is another one smaller here, but this one is out. And now I check whether there are other individuals of this species, but I can already see this is the only one. There is a very tiny one here, but this is completely dead already. So we would then go on with another beech tree. You remember we already recorded this one, but it is in a different height class. So we will have another additional line in our table, again for Fagus sylvatica. And the height class here is the second height class. Now the third height class even, because it has a height, not a length, of 80 centimeters. And we will also record this one. And this is how we will go on. You see we find 2 spruce trees here, one a little bit higher, another one nearly dead below here, and we would also record them separated for species and for height classes. For the browsing damage that I mentioned before, we can either count all the individuals that are browsed, or we can make a summary statement about the percentage of individuals that are damaged by browsing. So you see we found something here. In the second plot that we would install in the other direction, there can be much more or nothing. At the end, these 2 plots are put together as one observation, and with this we are averaging these very extreme observations already inside the single observations, which will likely make our estimates at the end more precise. If we use a very tiny plot area of 1 meter radius per subplot, which means 3.14 square meters for one subplot and 6.3 square meters for 2 subplots, a single individual will have an extreme expansion factor and will represent thousands of trees per hectare. Why we are not installing such regeneration plots in the center of our sample plot, where we assess also the standing trees, is because usually we are damaging the regeneration in the center of the plots. People are standing around, walking around, and taking a lot of measurements. And shifting these plots 5 meters to the north or to any other direction will deliver us more undisturbed areas for assessing the regeneration. Okay, I hope you learned something about the assessment of regeneration, and much more important, about the idea of cluster plots, because this is very important in context of forest inventories. We have never talked about large area forest inventories, for example national forest inventories so far, but there you can see that cluster plots are also used for the standing trees. Okay, with this we say goodbye and hope to see you in one of our next tutorials.
A presto!